Hello everyone, my name is Yapi Hao and my partner which is Chong Yong Tong, and today we are going to introduce our project, our networking project. And before we go in, let me introduce what was it. And we are studying the bachelor degrees, which is software system development in TAR UMG. And today we would like to present our fundamental of computer networks course assignment. So in our assignment, we are tasked as local area network engineers to design a solution for our company, which is EcoGo Logistics.
So now I will just talk about the subnetting for our network. Let's first start talk about what kind of method we are going to use for this network. We are going to be using VLSM method, which is also known as variable length subnet mask. The reason why we are using this method instead of something like fixed length subnet mask is because VLSM allows us to have very customizable length of addressing all the IP addresses for a given network. This kind of subnetting is more efficient than traditional method like FLSM because VLSM you can set whatever subnet size you want depending on the size that is required for your specific subnet. First of all, we have identified that we have multiple locations that have the largest amount of net hosts needed. The first location as such is location A. So as for location A, there are 40 hosts that are going to be occupying that subnet. In this case, we have to account for a 10% growth for this location A, which means that we have to increase the amount of hosts needed to 10% more, which is 44 hosts.
The same can be said for location D, which is the second largest subnet. In this case, we have 24 hosts with 1.1 times growth, which turns it into 27 hosts.
I will now pass it back to Yapi Hao to explain our subnet.
Okay, thank you, Chong. So right now, let me bring you guys to the subnetting table. So as we can see in this table, as we can see in this table, first of all, in the location A, we use the total number of host address, which is for 64. And why we use 64 is because of we have the host address needed, which is 44. So as we can see in for enough allocate the addresses for 44, as we only can use the total number of host address to allocate it is 64 bits. Therefore, in the location A, we use the 6 bits subnetting mask.
As for the rest of the subnets, it will be following the same theory, as in that we will be allocating the amount of usable hosts according to the amount of needed hosts that is required in an area. For example, in location C, since the location itself requires 15 hosts, allocation of 5 bits is required, as if you allocate 4 bits, there will be only 14 usable hosts. So therefore, you have to require 5 bits allocation of the network address for hosts, which in this case will bring it up to 30 usable host addresses overall. Next up, we are going to be talking about the address table of our network.
For our addressing table, we have decided to follow the IP addresses from the largest subnet to the smallest subnet. So as you can see, we have already laid down all of our IP addresses, and as you can see, we have assigned all of our switches as well as our end devices with their individual IPs. For our topology, we have decided to place the router onto location A, as location A consists of the most host addresses in our network, which is why we place it over there so that it is closer to the largest subnet. For location A, we've decided to link to 2 switches because of the amount of host devices that we need, as one switch is not enough to connect to a total of 44 end devices at once. We will require two switches for that. Moving on, we are going to talk about location D, the second biggest one. As here is a little inconvenience, which is that location A, B, and C are all located 100 meters between each other, whereas location D has a distance of 150 meters. That causes an issue that we cannot use a traditional copper cable, which is why we have decided to use fiber cable here, fiber cable connection, so that we can ensure that the stable connection is reachable to location D. We'll now move on to location B. Alright. Location B, which is the warehouse, which is divided into two floors. Because of this, we have decided to connect it to two different switches and put them in separate subnets. For the first floor, we have decided to connect both the human resource and finance department together so that they are linked by a single switch as a single subnet, as they have fewer devices and thus does not require that many connections. As for the last location,
Location C.
it consists of 4 laptops and a printer in 3 rooms each, which means that we have to account for 15 devices. And for this, we also decided to go with a single switch layout, as it will be sufficient to connect to all of the devices altogether.
Okay, therefore, right now, we will show. I will bring you all to show the IP configuration that we done in the IP address. So for this, which is the location A for the PC, PCA2. So this was the IP that we configured. So which is 192.168.1.5. So let me try in the human resources department, which is the PCB4. Click it and config the desktop IP configuration. So as we can see, we also have the IP configuration for the IP address, which is 192.168.1.164. So right now, after the IP configuration, I would like to bring you all to see the ping.
Ping from PCA3 to PCB5, which is as you can see, it is going to be pinging successfully. Alright, instead of pinging from the same PC again and again, let's try to ping from a different PC. So let's try to go to laptop C1, and we will try to ping PC A1. And as you can see, it is successful. Next up, we will be checking the IP addresses that are linked to the switches as from the router, as well as validating that we have set up our password for both the router and the terminal. Here we have typed in Cisco, which is our password, and we have successfully entered into it. Now we will enable, and you will have another password, which is also set properly. Okay, now that we are inside of the router command line, we will now check for the running config on the router. You can see that we have enabled a secret, which is now currently hidden for the enable line. Enter. And next up, you can see that we have configured all of the IPs for the ports interfaces connecting to the switches. And at the bottom here, we also linked line port and aux and VTY to password Cisco. Moving on, we are going to go to a different switch. In this case, we are using switch C1. And in the same case, we have enabled user access password, as well as the enable secret password. In this case, because of enabling secret password, when we are showing running config, you can see that the password is hidden by the running configuration, which does not allow us to see what the password actually is. And in this case, we also set up the password over here for this individual switch.
Overall, this is the summary of our networking assignment. I'd like to thank you for watching our presentation. Thank you very much.